Hello my dear students, in this video I am going to talk about elementary row operations. There are three elementary row operations that we can apply on any matrix. The first one is interchange. It means that we can interchange any two rows in the given matrix. We can multiply all entries in a row by a non-zero constant, and that is known as scaling elementary row operation. So we can take any non-zero constant and multiply it with all the entries in a row in the given matrix. We can replace one row by the sum of itself and a multiple of another row. It means that we can take any non-zero constant, multiply it with any row, and then add that row into the other row. So we can replace that row by another row which is the sum of itself and a multiple of another row. Let's try to understand how we can work out these three elementary row operations by taking one example. Let's consider a rectangular matrix. Whose entries are 1, -2, 1, 0, 0, 2, -8, +8, 5, 0, -5, and 10. One more thing which I want to mention here is that two matrices are known as row equivalent matrices if one can be obtained from the other by applying sequence of elementary row operations. And if we assume that we have two matrices represented as A and B, then we call these two matrices as row equivalent matrices if we apply a sequence of elementary row operations on A to get the matrix B, and we can apply sequence of elementary row operations on matrix B to get matrix A. In this case, we write the symbol of this wave and R overhead to show that these two matrices A and B are row equivalent matrices. So if we apply any elementary row operation, we get another matrix, and that matrix would be the row equivalent matrix of the given matrix. So in this case, for the considered rectangular matrix, if we apply any elementary row operation from these three elementary row operations, we get another matrix, and that matrix would be row equivalent matrix to another matrix by applying some elementary row operation. So let's work out the first elementary row operation, which is interchange of any two rows. Suppose that I want to interchange first row and second row, then interchanging first and second row can be symbolically represented as R1, 2. This is the representation R subscript 1, 2. It means that we want to apply the elementary row operation which is interchanging first and second row. Then the equivalent matrix equivalent to this matrix would be the first row would become the second row and second row becomes the first row. So that would be 0, 2, -8 and +8, and this would be 1, -2. This is 1, this is 0, and the third row remains same because we are not working on the third row. Here this matrix and this one are row equivalent matrices. That's why we are using this symbol, a wave sign and a R overhead. This matrix is obtained from this given matrix by applying the elementary row operation R12, which is interchanging first and second row. So this is how when we apply elementary row operations, this is how we write the symbols. R12 on this side by R12 means by applying the elementary row operation, interchanging first and second row, we get this matrix which is equivalent to this matrix. Okay, let's move on. Let's get another row equivalent matrix by applying elementary row operation on this matrix. So we are now getting the equivalent matrix from this matrix, which will surely be equivalent to this matrix, because if this matrix is equivalent to this matrix and this one is equivalent to this matrix, hence the first matrix is also equivalent to the last matrix. Now let's apply the first elementary row operation again. Okay, let's do the elementary row operation by R23. Now I'm sure that now you know what to do with this. R23 means interchanging second and third row. So the first row will remain same, minus 8 plus 8, and then we will change the second and third row. It means that the third row becomes second row and second row becomes the third row. So that would be 5, 0, minus 5, 10, and the third row the second row becomes third row, so that would be 1, minus 2, 1, 0. So this is how we work out the first elementary row operation, that is interchanging any two rows in the given matrix. Let's move on. Okay, let's move on. Let's get another equivalent matrix by applying elementary row operation on this matrix. Let's work out the second elementary row operation. The second elementary row operation says that multiply all the entries in a row by a non-zero constant. So we can take any constant and multiply it with all the entries in a row in the given matrix. Okay, if I write down by 1 upon 2 R1, it means that I have chosen non-zero scalar 1 upon 2 and multiplying that non-zero scalar with R1 means I need to multiply that non-zero scalar with each and every entry of the row 1. So row 2 will become same, row 3 will remain same, and the first row will become, we will replace now first row by 1 upon 2 times row 1. So that is 0 into 1 upon 2 becomes 0, 2 into 1 upon 2 becomes 1, minus 8 multiplied by 1 upon 2, that would be minus 4, and 8 multiplied by 1 upon 2 becomes 4 again. So this is how we apply the second elementary row operation, which is multiplication of non-zero scalar by a row. Okay, let's work out this elementary row operation again. Let's get another row equivalent matrix by performing 1 upon 5 R2. It means that I need to multiply all the entries of R2 by 1 upon 5. So the first row remains same, the third row remains same, but the second row is replaced by multiplying 1 upon 5 to R2. So that would be 5 multiplied by 1 upon 5, that becomes 1, 0 multiplied by 1 upon 5 becomes 0, minus 5 multiplied by 1 upon 5 becomes minus 1, and 10 multiplied by 1 upon 5 becomes 2. So this is how we work out the second elementary row operation. Okay, now let's work out the third elementary row operation. Get the row equivalent matrix, apply third elementary row operation on this matrix. The third elementary row operation says that we can replace one row by the sum of itself and a multiple of another row. Okay, let's write down that in a symbolic form. So if I perform the operation by R1 minus 2R2. It means that now I am replacing row 1 by itself and adding that row 1, I am replacing the row 1 by the sum of itself and minus 2 times R2. So I need to multiply all the entries of R2 by minus 2. Okay, let me write down this as more clear form. Let me write down as R1 plus minus 2 times R2. Now this is much clear. So we are replacing R1 by the sum of itself and multiple of R2, that is minus 2 times R2. So we are working with R1, we are replacing R1, so R2 will remain same and R3 will remain same. So we'll write down R2 minus 1, 2, 1, minus 2, 1 and 10. Replacing R1 by R1 plus minus 2 times R2. So that would be 1 times minus 2 becomes minus 2 plus 0. So that would be minus 2. 0 times minus 2 becomes 0 plus R1 plus 1. So that would be 1. Minus 1 time minus 2, that would be plus 2, plus R1 means plus minus 4. So that would be plus 2 minus 4 becomes minus 2. 2 multiplied by minus 2, that becomes minus 4. Minus 4 plus 4, that becomes 0. Okay, let's work out this elementary row operation again and let's perform the elementary row operation to get another row equivalent matrix by performing the operation R2 plus 2 times R3. It means that now I want to replace R2 by sum of itself R2 plus scalar multiple of R3, which is 2 times R3. It means that we need to replace R2, hence R1 and R3 will remain same. So we'll write down R1 first, write down R3 because that would not change, and R2 will be replaced by R2 plus 2 R3. So 2 times R3 becomes 2 times 1, that would be 2 plus 1, so that would be 3. 2 times R3 means 2 times minus 2, that would becomes minus 4 plus R2, that would be plus 0. So hence we get minus 4. Okay, 2 times R3 means 2 times 1, that would be 2 plus minus 1, so that becomes plus 1. Okay, so if we don't write plus sign, just write down 1, that would be same. Okay, 2 times R3, so that would be 20. Okay, there's a little mistake. I guess we have made some mistake. Okay, this was 0 here, so I mistakenly wrote 10 here. Let's remove this one. Let's remove this one from here, and this would be okay. So this would be like this one. Now this is fine. Now this is okay. So 2 times R3 is 2 times 0, so that becomes 0 plus R2, which is 2, hence the result is 2. So this is the row equivalent matrix of this one by applying the elementary row operation R2 plus 2 R3. Means we are multiplying R3 with non-zero scalar 2 and adding those values to the corresponding elements of R2. So this is how we apply elementary row operations on any matrix. We have considered rectangular matrix in this example, but that can be any matrix, that can be any square matrix or any rectangular matrix. Okay, let's take a summary of this discussion. First thing which I told you that there are three elementary row operations which we can perform: interchange, scaling, and replacement, right? Interchange means we can interchange any two rows. Okay, symbolically it is written as Rij, means we can interchange ith row and jth row, replacing ith and jth row. This is the first elementary row operation which we can perform. The second one is scaling. We can multiply any non-zero scalar, say k, with any row Ri. It means we can multiply any non-zero scalar k with Ri, ith row, where k should be non-zero. This should be non-zero. And third one is replacement. We can replace the ith row by the sum of itself plus scalar multiple of any other row, where k should not be equals to 0. So we can interchange any two rows, we can multiply any row with a non-zero scalar, we can replace any row by the sum of itself and scalar multiple of any other row. And if we apply any of these elementary row operations or sequence of elementary row operations, we get another matrix, and that matrix is known as row equivalent matrix of the given matrix. So that's all for this video. If you have any questions, queries, you can write them into the comment section. I will try my best to resolve those queries. In the next video, I'll be talking about how to apply these elementary row operations to find the solution of system of linear equations. Thank you.